Hello, my 7+ students. We're going to go ahead and take a look at 9-3 notes. And I actually broke it down into 2 days for you. Day 1 is going to be just rate of change, small discussion on slope, but then day 2 is going to be lots and lots of slope. So first, let's go ahead and get started with our vocab. Rate of change. It is a rate that describes how one quantity changes in relation to another quantity. So for instance, if I say $5 per book, I know that for each book, I'm going to multiply it by 5. So if I get 3 books, I'm going to take 3 times 5. So I'm changing one quantity in relation to another. Notice the next vocabulary word is linear relationship. We know that linear is just that word line. So linear relationship is the rate of change between two quantities stays constant. Go ahead and write that in with me. Which makes the graph of the relationship a straight line. So it stays constant. It's continuing to go up by the same amount. And then the last word that we are going to look at, and like I said, we're going to look at a little bit more on day 2, but I do want you to be aware of the word slope. It is the ratio of the vertical to horizontal change of a line. So in parentheses, I'm also going to write rise over run. And like I said, we will get into a little bit more of that on day 2. But just so that you are aware, the words rate of change and slope are exactly the same thing, but we use rate of change for like word problems. So that example that I gave you of $5 per book, that would be a rate of change, whereas slope is just kind of like the generic word that we use with like equations or with 2 points. So there's not going to be a word problem that gives us 2 different quantities. All right, so rate of change from a table. Does the data on each table have a constant rate of change? If so, what is that constant rate of change? And we are going to include labels. So this first example, all you're going to do is look to see, I call it the jump. So you're going to look to see from the X and the Y if the jump is going to be the same. So for instance, we know that in a table that looks like this is always going to be our Y value down here. So Y is the money, and the next is going to be the number of days. So for Y, I notice that from one to the next, the jump is like a -20. Same thing here. Our jump is a -20. And same thing here, our jump, a -20. Then looking up at our X variable, I see that our jump right here is a +2. Our jump is still a +2, and our jump, or what we're going up by, our rate of change, is a +2. Now, we always need to simplify the rate of change. So what I mean by that is that jump that you are using, we're always going to put the change, the ratio of the vertical to the horizontal, or the change in the Y. We're going to indicate that with this little triangle. That's called the change in the Y over the change in the X. So our change for Y, it was going down by 20. And then our change in X is it's going up by 2. No, I don't need to put a plus sign there. But then you always want to simplify that out. So we would say the rate of change here is -10. And then what that means based on the table is you would say we are losing $10 per day. So I know that we didn't say like, are we gaining or losing? But I know that if I'm going down, I'm not gaining that money, right? I'm losing it, or it's just going away. So you would just say like a loss of $10 per day. But notice that in that final example, I do have my 2 labels in there. I've incorporated those in. So our final answer right there is a -10. So yes, this does have a rate of change, and you would say the constant rate of change is losing $10 per day. Okay, example 2. Again, we're going to look at our change. So notice right here, I'm going up 12 for the distance. Then again, I'm going up 12 for the distance. Okay, and then this last one, notice that I am going up only 9. Okay, but that doesn't guarantee that it's not the same rate of change. So we do need to also figure that out for our x's. So again, here's our x value. I'm going up by 3. I'm going up by 3. and then I'm still going up by 3. So because this stayed constant the entire time, that means that this one would also need to stay constant with that positive 12. But just be careful because sometimes I may, quote, trick you and try and mess up our change in y's over our change in x's, meaning that when I take 12 divided by 3, I for sure get 4. Same thing, 12 divided by 3, I still get a 4 rate of change. But then when I take 9 divided by 3, that's what makes this so there's no constant rate of change. So you would say nope, which then also means on the graph, it's not going to be a line. It's no longer going to have that linear relationship. Okay. And then example number 3, number of dogs and pounds of food. So right here's our y's. So again, we're going to look at our rate of change. It looks like right here I'm going up by 5. Then right here it looks like I'm going up by 7.5. And then right here I'm going up by 2.5. So right now you're thinking, no, this is definitely not. However, you do need to also do the rate of change for our x's. So for our x's, you're going up by 2. Okay. Then we're going up by 3 is our jump. And then we're going up by 1. So yes, it looks kind of all over the place. But remember, how to find the rate of change is we're going to do the change in y over the change in x. So when I do the change in y over the change in x, I know it's 5 over 2. And then same thing here, 7.5 over 3. And then right here, it's a 2.5 over 1. If you were to calculate that, or if we just know the answer to that, every single one of those is going to equal 2.5, a positive 2.5. So because all of those change in y's over change in x's are all giving you the same answer, your final answer is that yes, this does have a constant rate of change. And so then it says, if so, what is the constant rate of change? Include labels. You would say 2.5 pounds of food per dog. So example 1 and example 3 do have that constant rate of change. And when it doesn't, you're just going to indicate that. So for instance, this example 2, you would say no rate of change. Just keeping that in mind. Let's go ahead down and look at it from a graph perspective. So from a graph, this is kind of just a concept summary for you so that you understand. You're going to read the graph always from the left to the right. So what I mean by that is from the left to the right, kind of like just as you're reading a book. So I'm working from 0 and I'm working my way to the right. So as I'm working my way to the right, you're letting me know if the line is going up, which means that it's going to be positive. If it's up, it's positive. As you're going from the left to the right, if you see that that line is going down, clearly it's going to be a negative. And if you see that it's from left to right, not doing anything, but just staying constant right there, you would just say the rate of change is 0 or that there is no change. So on a line, the rate of change is also called we said this up above. If you remember, go ahead and write that word. If not, hopefully we can look and see those words. It's not a linear relationship, yes, but slope and rate of change are interchangeable. Okay. Then the ratio of the vertical change to the horizontal change is also referred to as the rise over the run, which we very briefly mentioned up above. Okay, which means that you are going to go up and down first. So you're going to go up or down first. And then you're going to go to the right. Okay, and what I mean by that, the reason that you're always going to go to the right is we're going to work our way from the farthest left point to the farthest, or not the farthest right point, but to the next right point, which means that you're either going to go up or down, and then we're going to go to the right. Like I said, this is going to make way more sense when we actually look at slope tomorrow, but also just for this graph down below, it might make a little bit more sense for us as well. So the rise is the up or down, and then the run is going to be our running to the right. Okay. Also, you can count the vertical and horizontal distances between points, or you can use the formula. We're going to use M equals y2 minus y1 over x2 minus x1. And what I mean by that is that you're just taking 2 points and you are subtracting them. So you're going to subtract the y's, then you're going to subtract the x's, and then we're going to get a final answer. Okay, so down below, we know that the data in the graph below has a constant rate of change because the points for each circle are in a linear relationship. So go ahead and write that with me. Because they're in a linear relationship, what is the constant rate of change for circle 2? So circle 2, with including labels, I can see that these right here, this is a good point. This is a good point. The reason I know it's a good point is because it crosses at an intersection, is how I explain it. Same thing here. This one crosses at an intersection. This one right here is not a good point. It's just on a street. Okay, this one right here, definitely not a good point. It's not even on a street. It's just chilling. Okay, so for constant rate of change, we are going to take 2 good points and we are going to count to find the constant rate of change. So how we count is we always go up or down first because that's going to be our rise. So we always start with the farthest left point. So our farthest left point is right here. And then I'm going to go up or down to get to the next point on the right. So the next point on the right is up above. So I'm going to count it. I'm going to go 1, 2, 3 bunny hops. So that's going to be a positive 3. And then I'm going to move to the right. So then from that point, I'm going to go once and twice. And that is a positive 2 because I went to the right. If you go up, it's positive. If you go right, it is positive. But then if you go down, that's going to be a negative slope, which is what we indicated up above. Because you can also see that, like, as I go from the left to right, we can see that it's an incline. So because it's an incline, we're going to have a positive slope. So our positive slope is the rise, which is 3, over the run, which was 2. So what is the constant rate of change? We need to include labels. We would say the radius increases. Go and write that with me. The radius increases 3 centimeters every 2 seconds. Now, I know I have a lot of you and you're like, wait, why did we just leave it as 3 over 2? You can leave it as 3 over 2, or you can go ahead and simplify it down, because if you were to simplify that down to 1.5, you're going to get the same answer. It's just simplified. So you could have also said the radius increases 1.5 centimeters every 1 second. That is totally okay. But like I said, I have my rate of change. I found it by counting. I first went up or down, and then I went to the right, because rise over run. We are going to try this next one on your own. So go ahead and pause the video and look at circle 1, and see if you can count to create that rate of change. So I went ahead and grabbed my 2 points from circle 1. If you wanted to use that far left point, that's okay because you see that dot. However, it's not on an intersection. So that's why I'm like, you might as well just use this one at the number of seconds, which is 2, and at the radius of 5. I believe that's 5, yes. And then over here, the number of seconds is 6, and then the radius is 4. So what I'm going to do is I'm going to go up or down first because I'm rising. I'm getting out of bed first before I start walking to the bathroom. Okay, so I'm rising up or down. So I'm going to go down 1. So because I went down 1, this is the rate of change of -1. I'm going down. And then I'm going to the right. I'm going to go 1, 2, 3, 4 spaces. So right there, because I'm going to the right, that's a positive 4 spaces. So then how we're going to write our rate of change is you would say -1 over 4. There's our rate of change. And what that means is the radius decreases 1 centimeter every 4 seconds. But again, you could have also simplified that and said, hey, it actually goes down 0.25, or it goes down 1/4 of a centimeter every 1 second. Just make sure for your rate of change that you always include your labels. Alrighty, good luck on your problems.